Okay. That's looking at question 5. These are number patterns, right? So you to examine the first 3 diagrams given here. So here are the diagrams from uh these diagrams here. You are required to complete the table by determining the number of points of the intersection in the next 2 diagrams. Okay, so for us to get the next 2, we need to find like the pattern, the order and the rule of the pattern, right? So looking at the first position here, the first position is 3 intersections. 1, 2, 3. So maybe we can be multiplying by 3. Here's the position. That gives us 3, right? 3 into the first position, 3 into the first position, 3. Then 3 into the second position, that's 6. So it's not really the rule. We don't just multiply by 3. But if I check on something, let me say that I say n squared, right? That's position. First position squared gives me 1. So for me to get 3, I can multiply this by 3, right? This is going to give me 3. Okay, that's going to give me 3. Then let's look for the second one. If my position is 2 times 3, so I have 4 by 3. So it gives me 12. Let me say I have the third position, that's squared, and then times 3. So 9 times 3 is 27. So it means for the fourth position, right? For the fourth position, just gonna multiply. I'm going to multiply 4. I'm going to multiply it by itself, then by 3, right? So it's 12 times 3, right? Which this is going to give me 30. No, it's not 12. Actually, it's 16. 16 times 4, it's 48. Then there's 48. Then you have 5 all squared, which is 25 times 3 gives us 75. So this is 75 here. Yes. Now, what I know is that the position is square the position and multiply it by 3, right? That's the relationship we have there. And then the numbers are arranged. The numbers are arranged. Let's just the numbers are arranged in the following pattern. If the pattern is extended, what will the fifth number in the 100th row? Okay, we're looking for the 100th row. The number pattern is extended. The extended in the first, we have 1, 2, 3, 4, 5. So this is the pattern that I'm looking at. So if it is extended, so I have 25. I have 31. I have 37. Let's see, what's the difference here? It's 6. Difference is 6. So I need to multiply by 6n, right? And then I have to add something. I don't know, right? For the first one. Let's say the first one, that's tn, right? So let's take the first one. 6 times 1, the position plus something has to give me what? 25. So I need to add 19 for me to get 25. So I can say that this is 6n plus 19. That is my tn. So for the 100th one, so I'm going to put 100 plus 19 equal to, so 619. There we go. Then that will be for question 6. Question 6, what is an algebraic expression containing what is an algebraic expression containing two terms called? This one, they're giving you answers, they're giving you marks. They're giving you marks. Binomial, isn't it? Binomial. What are x and y in the expression referred to as variables? Variables are the letters and the alphabets in the equations, right? Or in expressions, right? Any variable is defined by A, B, C, so on, all the letters, right? We call them variables. And then simplify the following. The square root of 9 is 3. The square root of x exponent 4, it's x exponent 2. Square root of y is y squared. However, please don't do this thing. Don't do this. If you're given the square root of a squared plus b squared, and then you say this is a plus b. No, completely. Don't do this thing, right? Don't do that. If it's plus or minus, don't do that thing. Don't. It only applies when it's division and multiplication. If I have a squared divided by b squared, this is a divided by b. Now, this is correct, right? Number 3, a squared times b squared. A times b. This is correct. This is correct. So, as you can see here, my answer here, it's not squared, it's just y. Just y. Now, here, I'm expanding. X multiplies the x there, x squared. X multiplies the negative 3, negative 3x. Then I have the 5 multiplying the x and the negative 8. So this is going to be positive 5x minus 15. So I have x squared plus 2x minus 15. Now we get into this question here. So what should come into your mind also when you're dealing with binomials? Also check for the difference of two squares, because we have 25, which is a perfect square, and z squared is a perfect square. Negative 9 itself is a perfect square. Then you look at the denominator, you can see that 25 is the square root of no, it's the square of 5, right? 3 is the square root of 9. So difference of two squares, it's going to be 5z minus 3 with a different sign on the other bracket, or over 5z plus 3. Now, this is going to eliminate this. Then my answer will be 5z minus 3. Do not do this thing. Do not do this. Do not. These are things, misconceptions, right? Misconceptions. Avoid these misconceptions. So you can have 3x plus b all over 3x. This, it's not equal to b over the answer. It's not b, because I know you like doing this. No. Don't do that. 3x plus b over 3x is 3x over 3x plus b over 3x. Right? This can cancel that. Now this is correct. Avoid those things. Do not cancel. And then get into factorization. Oh, these are 3 marks. This is the same as that. 2 terms there. So I'm gonna have q minus r. 3x there, then minus 2. If you're still confused with factorization, right, these are the things you must remember with taking out of a highest common factor. Highest common factor. So if I have 2x plus 4, the highest common factor here, the factors of 2, it's 2x, right? 2 times x. The factors of 4, it's 1 times 4, is 2 times 2, right? So the common one for both, it's 2. It's common for both. So I'm going to factor it out. That is 2. Then it's going to be the highest common factor divided that. So it's 2x all over 2 plus 4 all over 2. 2 cancels the 2 there. You have x, then 4 divided by 2 is a 2. So in definition, highest common factor is going to be here, the first term all over highest common factor plus the second term all over the highest common factor. This can be applied in all of them. Another example, 3x squared plus x. The highest common factor here is x. So I'm gonna have x. So I have 3x squared divided by x plus x divided by x. So this is going to be let it be cosine. This is going to be, this cancels 1. So you have 3x. X over x is equal to 1. Now, getting here, back to the question. Here we divided everything by q minus r. What is common here? It appears on both. 2 is a common, x squared. Okay, only x is common. I'm gonna have 2x. Right, so 2x cubed divided by 2x. This cancels this cancels, then you have 1, so it's going to be x squared. Negative 10x squared divided by 2x. This is 5, right? Minus 5, then cancels 1, then you have x. You have next negative 28x divided by 2x. X eliminates the x. Negative 28 by 2 is going to give you a negative 14. There's your final answer, right? So you have 2x. So looking at the factors of negative 14, it's 7 and 2. 7 and 2 can give you a 5, right? So I have x. This is 7 here. This is 2. Then x. The sign goes to the bigger number.